In 1.4, you're going to do something that we've never asked you to do, and that is to simplify radicals down into their smaller parts. So before I forget, a radical is anything with this symbol that looks just like that. Some of you know this as a square root symbol, which it is. The only thing is that sometimes we don't just do square roots. Sometimes we do third roots and fourth roots, fifth, sixth, and so on. If you were in honors math 2, we would explore what it looks like for a third root, fourth root, eighth root, and so on. But for regular math 2, we are only going to be working with square roots. I just want you to know that it does exist to have third, fourth, and fifth roots. And in math, most every single thing you work with is an invisible 1. Square roots are the only thing that have an invisible 2. So when you don't see something here inside this little v, it's an invisible 2. It means your square root. It means you have to have 2 factors to break out. Now, how we're going to deal with problems goes with this. Don't write this down, but I want you to see it. You've seen this before, probably in 4th grade when you were learning your times tables. That's what this is. It's a times table where you do 11 times 4 is 44. Or 9 times 8 is 72. And there was something special about these yellow ones down the diagonal. These ones were special because they were perfect squares. They were made up of 2 numbers that multiplied by themselves to equal those yellow numbers. You could also figure out that the square root of 36 was 6, and the square root of 49 was 7, and so on. So these yellow ones had special properties about them because they broke down nice and evenly. But what would happen is if you had something that wasn't down that yellow row? How do you make it smaller without a calculator and without turning it into a decimal? That's the kind of math that we're going to do in the last section. So, for example, the closest you could do right now for the square root of 24 is you can go, well, it's smaller than the square root of 25. I know what the square root of 25 is. It's 5. And it's bigger than the square root of 16. It's bigger than 4. It's somewhere between 4 and 5, and it's probably closer to 5. So maybe 4.8, 4.9 is my guess. That's as close as you can come right now without a calculator or anything else. But that's what this paragraph states. We're going to simplify them. How do we do it? We're going to factor the coefficients inside using a factor tree. A lot of you know what that means. I'm going to show you an example on number 2. I want you to think of these radical symbols kind of as like as a jail cell. And the factors can't break out unless they have a partner that's exactly the same as itself. And every pair, one factor is going to break out. Anything that's in outside multiplies. Anything inside is going to multiply. So let's look at an example. I'm going to start and show you number 2. Number 2 says the square root of 24. You are going to first begin by breaking it apart into 2 numbers, and it doesn't matter which 2 numbers you pick. You can say 2 and 12. You can say 3 and 8. You can say 4 and 6. But whatever you do, once you get and you start breaking down the 24, don't forget to continue to break down any number until you're left with all the prime numbers. The 24 broke down to 2 times 12. The 12 broke down to 2 times 6. The 6 broke down to 2 times 3. So this is the same thing as the square root of 2 times 2 times 2 times 3. And if you don't believe me, 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. It works. This is not simplified yet. In order to simplify, we are going to look for pairs of squares. Pairs of factors that are inside the jail. So if I think of this as the jail, and I'm looking for a pair of any two numbers that are the same, I see a pair of 2s. I circle the pair, and what that is oh, these two can break out of the jail, and one of them will make it out. There's one group that has made it out. You do not write both of them. You write a single number. Now this 2 and this 3, they do not have a pair, so we put them back together. The 2 that's on the outside is going to multiply the radical 2 times 3. So my final answer is 2 root 6. And that's how you're going to simplify them. I want to show that to you in one other way. Earlier we said it was 2 times 2 times 2 times 3. Do you know what 2 times 2 is? And we know what 2 times 3 is? So 2 times 2 is 4, and 2 times 3 is 6. 6 times 4 is 24. That's the same thing. I could think of this as the square root of 4 times the square root of 6. What is the square root of 4? 2 times the square root of 6. It's the same answer. And it doesn't matter how you do a lot of these problems. Like if you chose to do 3 times 8 on the 24, you would have still gotten the same answer because the prime factors still match up. You'll still find the pair of 2s to get to that answer. Okay? Let's try one more for sure. Maybe I'll get to 2 more. We'll see. Number 6. There is a plus or a minus sign in front of this radical 216. Plus or minus just means that there's a positive and a negative answer. So we are going to multiply anything that pops out by this plus or minus, and it will be a positive and a negative. Now I don't know what goes into 216. Can't think of 2 numbers that are kind of big. So a lot of times I'll just say, oh, it's even. Even numbers are divisible by 2. And so I have to think, what's half of 216? I know half of 200 is 100. And half of 16 is 8. So 2 times 108 is 216. I hate to say this, but you're going to have to get used to doing this without a calculator. So I'm showing you strategies when the numbers are something you don't know. 208 can be divisible by 2 and 54, I believe. Every time you break it apart, we don't use it anymore. I'm going to break apart the 54. How about 2 and 27? 3 and 9, 3 and 3. So then what I'm looking for is I'm looking at this as these are all the prime factors that are inside this radical. These are every single thing that's inside that jail. So I'm going to rewrite it real quick. 2 times 2 times 2 times 3 times 3 times 3. And because these are square roots, we need 2 factors. For those of you in here who are advanced and you want to know what the honors kids are doing, we do third roots, which means you have to have 3 factors to break out, and only one would pop out. And they do fourth roots. They're looking for 4 factors, and then we'll throw letters and stuff in there as well, variables. That's how it gets harder. But for us, we have square root. I need 2. I circle that. A 2 can pop out. This one doesn't have a partner. I leave it there. Do I have a pair of 3s? Yes. A 3 can pop out. Does this other 3 have a partner? No. What do we do with the numbers when they don't have a pair? We multiply them. So the square root is actually going to be the square root of 6. What do we do with the numbers that are out front? They multiply as well. 2 times 3, and there's a plus or minus. We put the plus or minus right there. Plus or minus 6, root 6 would be our answer. Show of hands. Thumbs up if this is making sense to you. Thumbs down if you are confused. I do not see any thumbs down. I see a bunch of thumbs up, and I see maybe one thumb that looks slightly crooked. Okay, I'm not going to say who that is. It's a joke. Okay. This will be our last example, number 10, and then we're going to end our notes for part 1 today. I have negative 6 root 54. So what I'm going to do, just like I did before, is I'm going to look to see if I can break this down. If you don't know what goes into 54, you can always divide it by 2 since it's even. But I think some of you know 54. 6 times 9. If you do that, you can break apart the 6 in 2 and 3. You can break apart the 9 to 3 and 3. Once you break it apart, you don't use it. Some of you are going to need to write it out again, just like I did before. Others of you will just be able to look for your pairs right here. Some of you will circle them from your factor tree. And you'll take, oh, I see a pair of 3s. A 3 can pop out. And you're just going to draw a little arrow. And you're going to put your 3 out here. And you're going to cross it off. And you're going to look to see, does anything else have a pair? Does this have a pair? Does that have a pair? No. What do you do with it when it doesn't have a pair? You put it back together. And those are still inside the jail. Root 6. I say root 6, or I could say radical 6. Either one means the same thing. What do I do with the 3 and the 6? Multiply. 3 and 6 multiplies. Don't forget it's a positive times a negative, so it's going to be negative 18. And that is our answer. I'm going to stop your notes right there.